In section 2.2, we're focusing on equations of lines. We've already taken a look at this. So this first part is going to be a review for you. When we read the slope of a linear function, whenever we read any type of function, we read it from left to right. So a positive slope is going to be a line that moves up as I move from left to right. And that positive slope can be drawn anywhere on your coordinate plane. Negative slope is a line that's going to move down as you move from left to right. Remember, zero slope is my constant function. It's going to be flat, horizontal line. It has a zero slope. Undefined slope isn't a function. It just doesn't make any sense. We have a vertical line. Undefined slope. We can't give it a slope. To calculate slope, we label it as the variable m. We're talking about rise over run, which means we're interested in the change of y values compared to the change in x values. It's important that you have the y change in the numerator, the x change in the denominator. This is the same example we did last time where we got a slope of a negative 13/9. The more formal definition for slope that you have probably used in the past is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is fine, but it gets confusing as which point do you use as your first point, which point do you use as your second point, and the truth is it just does not matter. Remember, what matters is if I start with a y value, I have to start with that x value. That consistency in the point that you picked first is the one that matters. Okay, if you want to walk through finding the slope of this particular line again, refer back to our video for 2.1. We're going to move on and we're going to find some slopes for some new lines using the graph or given points on the line. Now, we're talking about this line right here. Does not have arrows in the end, but it should. It's a line. It goes through this point, negative 3, negative 3. I see that it goes through this point. It hits another point over here. This point would be 6, 0. This point is 0, negative 2. So when I'm talking about slope, I'm interested in rise over run. So how far am I going up and then over? This is my rise. My vertical increase, this is my run. My slope is going to be positive because I see that as I move left to right, it's going up. This one is a little easier for me to see and to measure exactly. If here on the y-axis I'm at negative 2, I go up to 0. So I'm going up 2, and then I'm moving over from 0 to 6, over 6. So my rise is up 2 over 6, rise over run, up 2 over 6. This is not in lowest terms. We always want to put things in lowest terms. I can divide out a common factor of 2, so I have a slope of a positive 1/3. What about this one? Well, I see that I have a negative slope, first of all, because my line starts high, keeps going down as I move from left to right. It goes through the point negative 3, negative 3 again. It also goes through the point 0, negative 4. And over here, I've got 6, negative 6. So I can see that I'm not rising, I'm falling. I'm going down and then over. So I'm moving down. I know my slope is going to be negative because of that. If I go down from negative 3 to negative 4, that is down 1. And then I'm moving over from negative 3 to 0. So over 3. Down 1 over 3. Well, down 1 over 3. Rise over run, down 1 over 3, and I'm moving down, so it's a negative. Negative 1/3 is my slope. What about this one? Here's my line that I'm interested in. I see that it is horizontal, moves straight across left to right. This is my zero slope. I have a constant function. And for the last one, right here is the line I'm interested in. It goes through these 2 points. Vertical line is an undefined slope. I could also say it has no slope. This one is not a function. Now I can give equations for these lines. This line, no matter what my x value is, what is my y value here? Well, my y value is -1. No matter what my x value is, y is -1. That's the equation for this constant function. Now this x value is -1 no matter what my y value is. So this equation is going to be x equals -1. I have a line that goes through every place where x is a -1. All right, then we have some examples of finding slopes algebraically. So let's look at the next page. And we're going to find some slopes algebraically. We're going to use our more formal equation for a slope. Change in y over change in x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1, whichever one we're more comfortable with. It doesn't really matter. So let's work through and find the values of these slopes. I was looking through because I thought I had, oh, there we go. Okay. Okay, so my slope is going to be, and it doesn't matter which y value I start with, I'm going to start right there. So -2 and the other y value is 11. So -2 minus 11. And then the denominator, I use those x values in that order. So that's going to be a -5 minus a -4 because my second x value is a -4. Well, -5 minus 11 is -13. Those are both negative values. I add them together. This stays negative. Subtracting a negative means adding the opposite. So that becomes -5 plus 4. These have opposite signs, so they cancel out. 4 of them, right? 4 negatives add to 4 positives and gives me 0, and I have one more negative left over. So I have a -13 over -1. A negative divided by negative is a positive. And anything with a 1 in the denominator is just a whole number. So my slope m is 13 for this line, positive 13. What about this next one? For this one, I'm going to do the same thing. We're going to start with our y values. 14 minus 0 is my numerator. My denominator, -4 minus 3. Well, anything minus 0 is just itself. So my numerator is 14. -4 minus 3 is a -7. What is 14 divided by a -7? This is just a division problem. Well, a positive divided by negative is a negative. 14 divided by 7 is 2. So my slope of this line is a -2. Over here, we've got -3, 5 and -3, 8. The first thing that I kind of noticed, I go, I see that my x coordinates are the same. That tells me that this line is going to be interesting. My change in y over change in x. So let's start with our y values in the numerator, 5 minus 8. And then my denominator is -3 minus -3. Well, 5 minus 8 is -3. -3 minus a negative, remember that we add the opposite, so that becomes -3 plus 3, and those opposites add to 0, so I've got -3 over 0. Okay, so this is a big red flag. 0 in the denominator, we can't divide by 0. Remember to ask me why we can't divide by 0 in class. Anytime I have 0 in the denominator, that is undefined. Division by 0 is not possible. To help you remember, division by 0 is not possible. No, we can't do it. No. So 0 in the denominator means our slope is undefined. What type of line is that? Well, remember that is a vertical line. What about this one? For this last one here, I see that my y values are the same. So let's see what that does to my calculation. I start with those y values in my numerator, 5 minus 5. My denominator is going to be negative 3 minus 2. Well, anything minus itself is 0, and my denominator is a negative 5. But you know what? When I have 0 in the numerator, 0 over anything, that's just 0. It does not matter what that bottom number is. 0 over anything is just 0. So my slope here is 0. This is my constant function. If I were going to graph it, it would be my horizontal line. And this particular horizontal line is going to go through the y value, 5. The constant function. I misspelled constant. Let's try that again. Constant function. 0 in the denominator, no, that does not work. 0 in the numerator, though, is okay. No problems with 0 in the numerator. 0 in the numerator is just 0. All right, let's move on and talk about different forms of our linear equation. We've got two main forms of the linear equation that we're going to focus on. Slope-intercept form is the most user-friendly. This is the one we use the most because it allows us to graph the equation. It gives us two major pieces of information. M is my slope, of course, and B represents my y-intercept. Because if I plug in 0 for x right there, that term goes away and I'm left with B. So it tells me where my graph intercepts the y-axis, and it tells me what my slope is going to do. So let's look at our equations. I'm seeing these are kind of oddly spaced. So I'm gonna define some boundaries here for our problems so that we can work those out. Identify the slope and y-intercept of each line. These are all, well, no, these two are solved for y, so they're already in our slope-intercept form. So I've got y equals mx plus b. My slope is 3. My y-intercept, where x is 0, 0 here, y is negative 2. For the next one, y equals mx plus b. Well, my slope is the coefficient on the x, and I don't have anything in front of x. Well, if there's not anything in front of the x, that means there's just one of them. So my slope is just 1. And my y-intercept, if x is 0, I got nothing. I got 0, right? So my y-intercept, where x is 0, y is 0. So that line is going to go through the origin. Hey, that's my parent function for my linear function. All right, this one is not in slope-intercept form. It's in standard or general form. So we need to put this in slope-intercept form by solving for y. We're going to solve for y by moving everything to the other side of the equation. I'm going to subtract 2x from both sides. That leaves me with negative y equals negative 2x plus 9. I'm keeping it in my y equals mx plus b form, y equals mx plus b, but I haven't finished solving for y. I've got a negative y there. So to finish solving for y, I need to divide everything by that coefficient of y, which is a negative 1. Negative divided by negative is a positive. That was my goal. Negative divided by negative is a positive. Positive divided by negative is a negative. So there is my slope-intercept form of this line. My slope is the coefficient on the x term. My y-intercept is the value. With x were 0 right here, I would be left with negative 9. Now what about these two? They look kind of weird and awkward. I don't know how to put them in slope-intercept form. So let's think about a quick sketch of a graph. Always go for a quick sketch of a graph if you're in doubt. Y equals 3. Well, y is 3 is right there. And y is 3 is going to be all the way across. So this line y equals 3 is a horizontal line right there. What do we know about the slope of this line? Well, the slope of a horizontal line is 0. It's my constant function. And it goes through the y-axis at 3. So my y-intercept is that 0.03. What about this line? X is 5. Well, where is x 5? I need to extend my x-axis. X is 5, 1, 2, 3, 4, 5, right there. And x continues to be 5 all the way up and all the way down. X is 5. Y is 3 there. X is 5 here. This vertical line is the line x equals 5. Well, this line has no slope. The slope is undefined. And it has no y-intercept. It doesn't intercept the y-axis. It has an x-intercept at 5, 0, but it has no y-intercept because it's a vertical line. All right, excellent, excellent. Moving right along. Remember, guys, you can always pause and rewind. If there's something I'm moving too fast through, you can always ask me questions about these later. I'm happy to go over with these. Now, if I have lines in a plane, they are either going to touch or not touch, right? Those are the only two situations. Well, if they don't touch, if I have two lines in a plane and they don't touch on the same coordinate plane, then these two lines are parallel. Here's an example of two parallel lines. Let's say this goes through at 4 and at -2. I'm going to give these two lines a slope of 2. So this one I could say is y equals 2x plus 4. That's my y-intercept at 4. And this one would be y equals 2x minus 2. There's my y-intercept at -2. Two lines that never intersect are parallel. Sorry, I can't spell today. Never intersect. Parallel lines never intersect, and they never intersect because they are slanted to the same degree. They have the same slope. Because they are slanted at the same degree and are not the same line, they never intersect. That means they have to have different places where they intersect the y-axis. So they have different y-intercepts. And I can determine their parallel if I put them in slope-intercept form. If I solve for y and I compare their slope and their y-intercept. Perpendicular lines. Perpendicular lines do intersect, but they intersect in a special way. They intersect and they form a right angle. Now my x and y axes also intersect and form a right angle. They are perpendicular to each other. Let's say I have two lines and I've got this line here and this line here. They intersect and form a right angle. This is my first line, this is my second line. I'm going to tell you that the slope of my first line, I can see it's negative, right? It's a negative, let's say it's a -3/2. The slope of my second line I can see is positive. M sub 2, slope of my second line, is going to be a positive 2/3. So I've got a -3/2 for the slope of my first line, zoom, and a positive 2/3 for the slope of my second line. These two lines are perpendicular to each other because they intersect at right angles. And I can compare the slopes and know if I have perpendicular lines because the slopes are related to each other. Can you see that relationship? One's positive and one's negative, so they're opposites. And the values are reciprocals of each other. I take the first one and I flip it upside down to get the second. So the slopes have two things in common. They are opposite. One's plus, one is minus. One's positive, one's negative. And they are also reciprocals. So I flip one to get the other. Okay, again, to compare slopes, I need to have my lines in slope-intercept form. These lines are given to us in slope-intercept form, so that is lovely. They are set up for us to compare and see what we've got. All right, so for these first two, I see that my slopes are opposite, but they're not reciprocals. The slope of this first line is 2. The slope of the second line is -2. They're opposite, one's positive, one's negative, but they're not reciprocals. So they are neither parallel or perpendicular. Those slopes, m sub 1 and n sub 2, are opposite, but not reciprocal. That would have to have a positive 2 and a negative 1/2. The reciprocal 2, it would be 2 over 1, or 1 over 2, excuse me. This is 2 over 1. That would be the reciprocal 1 over 2. Okay. What about these two? Well, the slope of the first line is 3, and the slope of the second line is a negative 1/3. So what do you think? One's positive, one's negative, and they are reciprocals of each other, so these two lines would intersect and be perpendicular to each other. On C, my slopes, this first slope is 7, the slope of the second line is 1/7. They're reciprocals. Does that mean they're perpendicular? They've got to be both of these things. They are not opposites, they're both positive. So those are neither perpendicular nor parallel. They have reciprocal slopes, but not opposite sign. What about here? I've got the same slope, so they can't be perpendicular. Could they be parallel? Same slope. Do they have different y-intercepts? Well, the slope of both of them is 5. What about the y-intercept for these lines? The y-intercept for here, if x is 0, y is negative 2. What if x is 0 here? Well, if that's 0 and there's not another value out there that is 0, so they have the same slope and different y-intercepts, these two lines are parallel to each other. Okay, moving right along. Remember to pause, slow down, rewind, whatever you need to do to make sense. We're going to talk about our next form of the linear equation. We've got our standard form, or standard or general form. Can't remember what this book uses. Standard or general form. Ax plus by equals plus c equals 0. We've got our slope intercept, which is the form that's most useful to us, y equals mx plus b, where we've solved for y. But what if we don't have, all we have is points, maybe we have a slope and we have a random point, but we don't have an intercept? Well, that's when we use the point slope form. We know a point, we know the slope, can be any point, doesn't have to be an intercept. I'm going to use the point slope form. This is where you start, not usually where you finish. If you know slope and any point on the line. So I've got slope and I've got a random point, and I plug in those values. Okay, keeping my point slope form in mind. Sorry, I lost track of what page I was on. Keeping my point slope form in line, I'm going to write the equation of this line in slope intercept form, but I need to start with my point slope form because I know a slope and I know a random point on the line. All right, here we go. So y minus something equals m times x minus something. Well, my slope is negative 2, my x coordinate is negative 3, and my y coordinate is 4. So that's my starting place. I've got y minus 4 equals a negative 2 times minus the negative gives me x plus 3. The first thing I'm going to do, order of operations, is I'm going to distribute this negative 2. But this right here, if if my MATLAB asks for it, this is my point slope form. This would be my stopping place if it asks for point slope form. But we're not going to stop there. We're going to go ahead and put it in slope intercept form because that makes our life easier. So I would distribute that -2. So I've got -2x, -2 times 3 is a -6. And then I have to finish solving for y. To solve for y, I need to add that 4 to both sides of my equation. So I get y equals -2x, -6 plus 4 is a -2. There's the equation of my line in slope-intercept form, y equals mx plus b. Then this one is a follow-up for this. Find the equation of a line that is parallel to that line. Well, parallel line has the same slope, different y-intercepts. Same slope, different y-intercepts. So same slope, y equals -2x, and then I just have to use a value that is not -2. I can use +2, I could use 0, I could use 7, I could use -313. I'm going to put plus 6. This has the same slope and different y-intercepts, so it's going to be parallel to the line I just found. Okay, one more example here. Slope and a point on our line. So we're going to plug in what we've got. Y minus something equals slope times x minus my x coordinate. What am I plugging in? Well, I am plugging in +3 for slope, -2 for x, and -1 for y. I clean this up a little bit. Y plus 1 equals 3 times x plus 2. That's my point slope form of the equation if I'm asked for it. But I usually don't stop there. I usually want it in slope intercept form. So I would distribute the slope. And then move that constant over so that I've finished solving for y. There's my slope intercept form. This time I need to find an equation of a line that is perpendicular to that. Well, what do I know about lines that are perpendicular? I know they have opposite and reciprocal slopes. That's the main goal, opposite and reciprocal slopes. So if this line has a slope of 3, this line has a slope of a negative, and then the reciprocal 3 of 3 is 1/3. So I can say, all right, I've got a -1/3 x, and I can keep that +5. I could change it. Does not matter. What matters is that it's going to have the opposite reciprocal slope. Okay, and if those of you who like things all in one nice neat place, here is your nice neat place. To write an equation of a line in slope intercept form, if you do you have the slope? If your answer is yes, then you plug that into your equation. If your answer is no, then you find the slope. Remember that if you know 2 points, you're going to use m equals your change in y over change in x formula. If you don't know 2 points, but you know that it's parallel lines, then the slope of the first line is the same as the slope of the second. If you have perpendicular lines, the slopes are going to be opposite and reciprocal. Opposite and reciprocal slopes. All right, your next question. Do you have a y-intercept? If the answer is yes, you're going to use the slope-intercept form. If your answer is no, you don't have a y-intercept, you have a point, but it's not the intercept, then you have to use the point-slope form of the equation. And you will solve for y to put it in slope-intercept form after. So there's your starting place based on, I forgot to write yes, based on your answer to those two questions. How you find the equation of a line, no matter where you start and what you're given. Okay, let's do some examples. We are not going to do all of these. We're going to do 2 or 3. And if you have class with me, we can finish these in class, or better yet, you finish them on your own and then come to me and we will check them and see how you did. If you don't have class with me, if this is not an in-person class, then you can get with a tutor, you can contact me later and we can deal with it that way. Okay, so let's see what we're going to go through and do. Let's start with this one. 0, if x is 0, I know that is a y-intercept, and I know my slope. If I know my intercept and my slope, I get to start in the form y equals mx plus b. I just plug in the right information in the right spot, and I have the equation of my line. This time, though, I know a point, but it is not the y-intercept. I also already know the slope, so that's good. But since it's not the y-intercept, I have to start in the other form of my line, my random point slope form of my line. And I plug in what I know, y minus the y value, so y minus 2. Slope is 6 times x minus the x value. Well, minus the negative 3 becomes plus 3. So I'm going to go ahead and mark that down. I need to distribute the 6. Multiplication distributes across addition. So I have y minus 2 equals 6x plus 18. And then I do the opposite or inverse to finish solving for y. I'm subtracting 2 here, so I add it to both sides to move it over. Y equals 6x plus 20. Excellent. All right, let's look at C. I don't have a slope. I have 2 points. And this point is my y-intercept. But since I don't have the slope, I have to start by finding the slope. So I've got change in y over change in x, change in y values. There's my y values right there. So I'm going to do 5 minus 8, and then my x values, 3 minus 0. 5 minus 8 is a negative 3, 3 minus 0 is 3, so my slope is a negative 1. There's my slope. Now I know both my slope and my y-intercept, and when I know both of those pieces of information, I can go straight to my slope-intercept form of the equation. So my slope is negative 1, my y-intercept is 0, 8, so plus 8. I don't ever have to have a 1 written as a coefficient, it's understood, so I'm going to go ahead and change that to negative 8, negative x plus 8. All right, I'm going to leave these last 3. You got 2 points. Neither one is an intercept. So you are going to have to first find the slope, and then you can't go straight to the slope-intercept form because I don't know the intercept. So then I'm going to have to use that slope in either one of these 2 points. It doesn't make any difference. Either one of those 2 points in my point-slope form of the equation. All right, down here, I know my y-intercept, so that's great. And I've been given information about a line. I know the slope of this line, so I can figure out the perpendicular line, what slope that would have. This is not an intercept, so I'm going to have to find the slope based on this information and then plug it into point slope form. Once I find the slope here based on this information, I have an intercept. So I am going to find slope, and then I can use slope-intercept because I know my intercept. Here I have to find my slope, but then I have to use the point slope form to start with because I don't know my intercept. I'm going to use that information to find my slope and then start with the correct form of the equation. Okay, like I said, we will finish those up in class if you have class, or you can contact a tutor or meet with me if you need to go back over those. All right, last thing today, we're going to do an application because this is business college algebra. We need some business application problems in here. Now, revenue, cost, and profit. Revenue is the money you bring in. Revenue is the money you bring in. Revenue is going to be like if I'm selling shoes, how much I charge per pair of shoes, that's my revenue. So it's the price times the quantity sold. If I'm selling shoes for $50 a pair and I sell one pair, I brought in $50. If I sell two pairs, I brought in $100. If I sell 4 pairs, 4 times 50 is $200 I'm bringing in. Now, revenue is not the same thing as profit. Revenue is not the same thing as profit. Cost comes into the idea of profit because I have to figure out how much it cost me to make my shoes in this example. And then the difference in the cost and the revenue is going to give me my profit. So let's go ahead and write that down. The revenues minus the cost gives me my profit. This is my revenue function, revenue of however many pairs sold. Here's my cost function, the cost of making however many pairs. Okay, and cost comes in fixed costs and variable costs. So fixed plus variable costs. And the variable costs are going to be times the quantity. So in my shoe example, let's say it cost me $10,000 to set up to make the shoes. $10,000, that's my fixed cost. If I just make one pair of shoes, it still costs me $10,000 to get set up to make my shoes. Variable cost is the materials per pair of shoes. So if, let's say it cost me $10 to buy the materials that it takes to make one pair of shoes. So for each pair of shoes I make, $10 plus that fixed cost. So if I make one pair of shoes, that pair of shoes cost me $10,010 because the fixed cost. Okay, you know what? That's a really good introduction here. Oh no, we're going to go ahead and finish. We'll do it. Okay. Monthly revenue and cost for the Webster Cell Phone Company are determined by the number of phones, T, produced and sold as shown in the graph below. So we've got our revenue function here. Revenues right there. And then we've got our cost function right here. So how much we bring in versus how much we spend. And we're talking about cell phones in the thousands. Find the approximate revenue for selling 28,000 phones. So revenue means I'm looking at my, I just circled the wrong color. Let's color code this. Revenue I marked in blue. So for revenue, I'm interested in 28,000 phones. Cell phones in 1,000, 24 to 32, that's a jump of 8. So 28 is going to be about here, 28,000. When I go up to 28,000, there's the mark on my revenue line. The revenues for selling 28,000 phones is $2.5 million. That $1 million matters. Or I could say $2,500,000, but I've got to make sure I got it. I can't just say $2.5 because that wouldn't be correct. Then it says calculate the amount of profit. Oh, I skipped down. See, there's an example of me making a mistake. And if you guys were there with me, you would have already told me to fix that. Okay, I put the two answers on different lines. There's my revenue, and I wrote my revenue two different ways. It means the same thing. Now we're going to look at cost. Approximate cost for selling that many phones is right here, and that's $1.5 million. So $1.5 million, which could also be written as $1,500,000. Same thing. Now the profit is the difference. Now my revenues are higher than my costs, so I did have some profit. What would be the profit from manufacturing 28,000 phones? Manufacturing and selling. What's the difference between my revenues and my cost? And that difference is $1 million. Also $1 million. Write it either way. The break-even point, however, is where I literally break even. I have brought in as much as I've spent. So my revenues are equal to my costs. That's sloppy. Or I could say that revenue minus cost is 0. I can think about that either way. For what number of phones manufactured did the company break even? Well, cost and revenue are the same here and here. So at 12,000 and again at 48,000, the company breaks even. Revenue and costs are the same. Now, anything less than 12,000, revenue drops below cost. Anything more than 48,000, revenue drops below cost. So this right here is the sweet spot. This is where they're making money. So how many phones should be sold each month if we're going to make a profit? Well, between 12,000 and 48,000. Because it's only between those values that we're making profit. So is it more profitable to make and sell 40,000 or 44,000? Ooh, what do you think? 40,000 phones is right here. 44,000 is right here. Which one is more profitable, do you think? Well, if I look at how far above revenue I am at each of those, I see that this distance from revenue to cost here, revenue is a lot higher than cost, a little bit higher than cost. So I'm making more money here. So it's going to be more profitable to make and sell 40,000 because the gap is bigger. Between our revenue and cost function there. My revenues, greater revenues for the cost associated with that. Does that make sense? Okay, all right. That is it. That's our section 2-2. Make sure you kind of put notes in the margin for things you want to ask about.